All right, Year 9, I'm just going to quickly do one of the questions that we did during the week on surface area, and I will look particularly at this question here, question 9. We did it in class, and it's very similar to one of the questions on your assignment. So what we want to do is we want to find the surface area of, well, they call it a log, but usually it's a metal pipe or tubing or something like that. So the surface area of the shape that's given in the diagram down here. So essentially, to find the surface area of this shape, we've got four main areas. We have the front bit, which is an annulus, a circle with a hole in it. We have the back bit, which is the same annulus, a circle with a hole in it. We have the curved surface area on the outside. And here's the tricky bit. We have the curved surface area on the inside. So let's make that a little bit simpler. Well, the front and the back are the same. The two faces are the same. So I've got two annulus plus the big curved surface area plus the small curved surface area. Let's work out how we do that. Well, the front bit is a circle with a hole in the middle. So that's just going to be 2, and you need to use parentheses here. Pi by the big radius squared minus the small pi times the small radius squared. And that'll give me the area of the annulus. The curved surface area, we know from our surface area formula, it's 2 pi by the big radius by the height. And the height's not going to change for either curved surface area because they're the same length. The small surface area, curved surface area, is 2 pi little r h. Well, this is pretty easy now because I've only got two variables to put in. I've only got the radius and the height. And when I say two variables, I should say 3 because there are 2 radii. So let's go along. First of all, 2 pi. Now what's the radius of the big one? Well, the diameter is 60, so it's times 30 squared. Let's fix that 3 up. Minus pi times the little radius. Well, the diameter is 20, so it's 10 squared. Now, keeping with this, 2 pi times the big radius, 30, times the height. Now, how far back is it? Now, this is where they get a bit tricky. Here, it's 3 meters, and we need to realize that we want this in centimeters. So 3 meters equals 300 centimeters. So they've been a bit tricky there. So let's put 300 in here. Plus 2 pi times the small radius, 10 times 300 again. Now, then it just becomes a calculator exercise. This is the most important line though, because this shows all your substitutions, and anyone looking at it can realise, particularly if you've stepped out your working, what you've done, and if you've made a mistake, or if you've typed in the rest, or put in the right values. So here we go. 2 bracket pi times 30 squared minus pi times 10 squared, close the bracket, plus 2 times pi times 30 times 300 plus 2 times pi times 10 times 300. Excuse me. And our answer, or the answer I get on the calculator, is 80,424.6 77193. And they want the answer to 1 decimal place. So then I'll round it. 80424.8. What units was I using? Centimetres. What am I finding? Centimetre squares. And that's the answer. So look at where the issues are with this. Making sure that we get the annulus at the front and the annulus at the back. And we add the two curved surface area, the outside and the inside. Because remember, surface area is the amount that is actually outside to the surface. And if we had to paint it, what areas would we need to paint? The other trick was realizing that the length of the shape was in meters and we had to convert that to centimeters. So I hope that helps you with that question and the question on the assignment.